Hello. So the question is, in the final uranium radioactive series, initial nucleus is uranium 23892. The final nucleus is Pb 20682. When the uranium nucleus decays to lead, okay, the number of a particle, okay, the number of alpha particle is, okay, and the number of the beta particle emitted is. So basically in this question, we have to find the alpha particle and the beta particle. Let us talk about for the alpha particle very first. So alpha particle is basically helium particle which is having 2 He, which is 2 He4. Okay, now so basically whenever there is a alpha particle is emitted, there should be a decrease of the 2 with the atomic number. As you can see this, its atomic number is 2 and decrease of the mass is 4 number. Okay, that simply shows what? That simply shows that let us talk about for the uranium 238. Okay, for uranium 238 and it is 92. So uh, when it will emit the alpha particle, it's, let's say, daughter nuclei will be A, for which now the atomic number will be 90 and the mass should be 234. Okay, then the alpha particle will emit it. And in this question we have given the uranium and the final nucleus is Pb is given to us. So now let us try to find the alpha particle, the number of alpha particles. So the number of alpha particle. To find the number of the alpha particle emitted, you can find it by simply saying that the in the very first we have 238 atomic number and the very last we have 206 and divide it by the 4 because the 4 is the atomic mass of the alpha particle. So when you divide it, you will get the 32 divided by 4. So you will get total 8 number of the alpha particles that are emitted. Okay, so now we have what? We have 8 alpha particles. Okay, so we have 8 alpha particles. So if there are total 8 alpha particles, so the atomic number decreases by, so you can find the atomic number decreases by, then atomic number atomic number decreases by, as I told you earlier that the whenever alpha particle is emitted, there is the decrease in the atomic number is 2. So if there are 8 alpha particle emitted, that means it shows that 2 into 8, which means 16 is the decrease, the number of the atomic number. Okay, so there is a 16 numbers which is decrease in the atomic number. So now it will be from in the initial we have given the atomic number is 92. So now it will be from 92 to from 92 to 92 minus of 16, you will get 76. Okay, so we have the 76 is what it is, atomic number. It is atomic number after after emitted 8 alpha particle, it has 76 atomic number. Understood? So basically in the very first we have the 8 alpha particle that is emitted. First answer is what? There are 8 alpha particle emitted. Now the atomic number is 76. So let us talk about for the beta particle. So when beta particle emitted, for the beta particle, atomic number increases. Okay, atomic number increases by 1. Okay, so it will be increases by 1. That simply shows what? That the number of the beta particle, the number of beta particle emitted, you can find it by simply saying that at the last we have 76 atomic number and in the very first we have and here we have given 82 atomic number P for Pb. Okay, it is 82. Okay, so what you have to do, you have to just here subtract the atomic numbers 82 minus of 76. This is for Pb, okay, which is our last product. Okay, so 82 minus 76 will shows there are total 6 numbers of the beta particle. This is what? Number of beta particle. Okay, so there are 6 number of beta particle emitted and 8 number of alpha particle emitted. Thank you.
Hello, we are given with a question, and the question says the radioactive decay rate of a radioactive element is found to be 10 to power 3 disintegration per second at a certain time. If the half-life of the element is 1 second, the decay rate after 1 second and after 3 seconds is what? So initially the decay rate initially be R naught, right? So at t equals to 0, it is R naught. So that is equal to 1000 disintegration per second, right? So we can write it disintegration per second, correct? Now what we have been asked is after one half life, what would be the decay constant? Since R is proportional to the decay rate is proportional to lambda into n, right? So R is directly proportional to 1 over T half. So what we can say from here is that R at 1 second would be equal to R at 0 second by 2 power 1. So how much is the time spent that n time is being n second after n second, it would be R naught by 2 power n. So after 1 second, it would be R naught by 2 power 1. So that would be 1000 by 2. So that is 500 disintegration per second, right? And after 3 seconds, R naught by 2 power 3. So that would be 1000 by 8. So that turns out to be 125 disintegrations per second. So we have here 500 and here we have 125 per second, right? So this is the answer. Thank you.
Hi, the question is, a rock is 1.5 into 10 to the power 9 years old. The rock contain of this uranium-238 which disintegrate to form this uranium-236. Assume that there was no Pb206 in the rock initially and it is the only stable product formed by decay. Calculate the ratio of the number of nuclei of this uranium-238 to that of this Pb206 in the rock we have to find. Clear? This ratio we have to find. Half-life of this uranium-238 is given, that is equal to 4.5 into 10 to the power 9 years. Clear? And it is also given that 2 to the power 1 by 3 is equal to 1.259. Clear? Now we can see that uranium-238 disintegrate and this is the stable product. This Pb206 is the stable product. Clear? Now let us consider N naught is the initial number of atom and Nu is the number of atom after some time t. Clear? Now we can find this ratio. N divided by N naught ratio we can find. So we know that Nu n divided by this N naught is equal to 1 by 2 and this is equal to N. Clear? Where N is what? Where N is equal to number of half-life. Number of half-life is this. Clear? So N is equal to, from here we can find, and N is equal to what? T n divided by this T half. T half we can write this. Clear? So N is equal to T divided by T half and this is equal to what? Number of half-life. Clear? And the half-life we know, half-life is the time in which half of the substance disintegrate. Clear? And the half is the present after this half-life. Clear? Now from here we can write, so from here we can write this is equal to Nu and divided by this N naught is equal to, we can write 1 by 2 to the power N. N is equal to T and divided by, we can write T half we can write, clear? From here we can write Nu and divided by we can write N naught is equal to 1 by 2, and in this question it is given that T is equal to 1.5 into 10 to the power 9, and T half is given that is equal to 4.5 into 10 to the power 9. So after solving this we can find this Nu value. So number of this uranium atom after some time, this is equal to N naught into 1 by 2 and to the power this. We can write to the power 1 by 3. This we can write, clear? Now, we have to find the ratio of Nu by NPV. So NPV is the product. So after some time, this NPV is equal to number of this PV atom is equal to what? This is equal to, we can write from here, this is equal to N naught and minus Nu, clear? So this is what NPV after some time. So from here we can find this NPV, then we can find the ratio, clear? So from here we can see that this is equal to N naught minus Nu is what we can write? N naught into 1 by 2 and to the power this 1 by 3, this. Now N naught we can take common, so 1 minus we can write 1 by 2 and to the power 1 by 3 we can write, clear? Now we have to find the ratio of this Nu and divide by NPV ratio we have to find. So let us consider this is the first equation and this is what NPV we can write, and this is we can write second equation, clear? Now from these two equations we can find the ratio, clear? Now a ratio we have to find. What ratio we have to find? Nu and divided by NPV ratio we have to find. So Nu and divided by NPV, and this is equal to, we can write from this first equation, this is equal to N naught into 1 by 2 and to the power 1 by 3, this, and divided by we can write N naught into 1 minus 1 by 2 and to the power what? 1 by 3 we can write, clear? This. Now from here we can see that this N naught and N naught cancel out to each other. So this is equal to 1 by 2 to the power 1 by 3 we can write, and divided by we can write this is the 1 minus this is equal to, so from here we can write this is equal to 2 minus 1 we can write from here, clear? So from here we can write this power is only on this, we can see from here. So just 1 second, this power is only on this we can write, clear? So in this way we can write, clear? So from here we can see this is equal to 1 and minus we can write 1 divided by and 2 to the power 1 by 3 we can write, clear? This. Now we have to solve this, and after solving this we can find this ratio. So from here we can write this Nu and divided by this NPV ratio is equal to, we can see from here, and this is equal to, we can find from here 1 and divided by we can write 2 to the power 1 by 3 and minus 1 we can write, clear? So from here we can say that this is equal to 1 by, and this value is given, 2 to the power 1 by 3 value is given, and this is equal to 1.259 is given in the question, 259 and minus 1 we can write this. So from here we can find the ratio, and this ratio is equal to, from here we can write Nu and divided by this NPV is equal to, we can write 1 by this is 0.259, clear? Now after solving this we can find this value, and this is equal to 3.86, this, clear? So this is the required ratio we can see, clear? Hope this answered your question. Thank you.